Okay, something like here's this block, and this is a serious block because it's 350 kilogram, which is like 770 pounds or something, almost 800 pounds. And then here comes this bullet coming at it like this. The bullet goes in at 1,200 meters per second, comes out at 900 meters per second, and then this gets some velocity which we don't know. Okay? Now this is like an interesting problem. It's interesting how they worded it, because you'll notice they're asking for F and delta T. So what does that make you think of right away? It should make you think of impulse right away. And so then you sit there trying to figure out like how to get impulse out of this. And yeah, that's a difficult one because they're asking for the two things over there. So you drop back and punt, right? And you say, well, okay, I don't know how to do this. Well, start from the beginning and say to yourself, what do I know? What is asked for? And if you go through that a couple of times, that little mantra, then you'll get it. Because that's what happened to me. I was sitting here looking at this problem, and I'm like, oh, okay, oh, wait, it's impulse. Wait, no, it can't be impulse because I don't know both of those things. Look what we have, VI, VF, and X. VI, VF, and X. Now, how the heck, we must be able to use mass, VI, VF, and X to relate to F and delta T. Okay, how can we do that? How do those things relate? How do VI, VF, X, and T, how can they relate? Yeah, well, if we find the acceleration, we can find everything. Does that make sense? There's also this handy little equation that comes into play sometimes when you have a constant acceleration. Do you remember what is that? Average velocity. You can find this. What is the first definition of average velocity? Yeah, just like distance over time. And then the second is the mathematical definition of average, which is just V plus V0 over 2. From this, you get something like X equals 1/2 V plus V0 times T. Little simple equation that you can derive anywhere, anytime, just by the definition of average. And from this, you can calculate the delta T. Right, of course, so we just say T is equal to 2x over the sum of the velocities. So it's 0.6 divided by 2100. What do you get when you do that? Anyone?
2.86 times 10
2.86 times 10 to the minus 4 seconds. Does that seem reasonable? Yeah, it's a bullet going through a piece of wood, or whatever it is, block of something. Yeah. This right here? Oh, this is just, I just took the definition of average and set it equal to itself to get this. Did you have to do this? No, not by any means. What is the most obvious thing that comes in your mind when you see this? Because we're back to chapter 2, right? It's like all the basic equations. And then you look at your formula sheet because you have no freaking clue what you're supposed to do. And lo and behold, what's the second equation in your formula sheet? Yeah, so if I do this the way that uses your formula sheet, I say V squared equals V0 squared plus 2AX. Now I can find A. A is V squared minus V0 squared all over 2X. Okay, now once I find A, then I can go, aha, the definition of velocity, the definition of acceleration, right? And the definition of acceleration is V minus V0 over T. So T will equal delta V over A, and I can get my A. So go ahead and work that. So once again, you can see, actually you don't need to type it in, you can see clearly that these two things are equal, and that's how we get the time. Now, of course, if you do it this way, you still got to find, well, no, actually you don't need to, because then you could go ahead and use impulse. So if I found this first by using the averages, the average velocity, then I would go ahead and use F delta T is equal to M delta V. I would use this to find F, because I know M and I know delta V. Does that make sense? Yeah, if I went ahead and did this to find t, then I could just use this a and multiply it, because I could say is equal to ma. Actually, the interesting thing is we could again try to do this both ways and see what happens. M delta v over delta t here. Things I guess we don't need. And what number? 2650? 26,250 newtons. Negative? Yeah. What's the easiest way to figure out the velocity of the block? Yeah, conservation of momentum is perfect, right? So we can say Pi equals Pf. What was moving in the beginning? Yeah, so it's just P1 equals P1 final plus P2. I guess I'll put final just to make it clear. And yeah, I should have put, this is V1. V1 initial, V1 final, just to be clear with everything. So does everyone see how you're going to find V2 that way? Just for grins. Okay, so we M1 V1 equals M1 V1 final plus M2 V2. Okay, V2's right here. So I'm going to say V2 is equal to M1 V1 minus V1 final over M2. This velocity, M1, right here, is up here, right? 1,200. That's 1,200 meters per second. And then this velocity right there, V1 final, is 900 meters per second.